Hello, everybody, and welcome to another episode of Life's a Breach. This is the third or fourth episode, I think, that we've done in this series, with many more to come. Today, we are going to be diving into machine learning. So machine learning, it's absolutely everywhere, and I do mean everywhere. It is in chatbots online. You see it in robots, in the physical world. It's powering e-commerce platforms behind the scenes. Tons of areas that are you interact with constantly. So we're talking about machine learning, or ML. It's a fantastically useful tool. In most cases, there are areas where there are advantages, there are areas where there are disadvantages. We are going to dive into the wonderful world of ML here in today's stream. As a reminder, we are live here on LinkedIn, assuming that all the technology and all the pipes have connected correctly. So with that, if you have a comment, if you want to join the discussion, drop a comment. We will address it as it comes up. If you're watching this on demand, thank you. Please, we continue to monitor these discussions. This series only gets better the more interaction we have. So remember that as we go through. And without further delay, here to help us cut through the hype and learn more about machine learning systems is Nithya Manickam. She is a principal data scientist here at Lacework. Nithya, thanks for joining us today.
Thank you, Mark.
Yeah, I think this is going to be really exciting because there is a ton of excitement around machine learning, but I think there's a ton of misconceptions, as is sort of standard with any really complex technical topic. Let's start with something that I'm 99% sure is going to be a pet peeve of yours. It tends to be a pet peeve of almost any data scientist I meet. So, and if it's not, that's totally fine as well. But we'll tackle this one right out of the gate because I think it really sets the stage. Artificial intelligence, or AI, versus machine learning. A lot of the time they're used interchangeably. Is that correct or incorrect?
It is like AI and ML are not exactly the same, right? Though ML is a subset of AI. So if you think of AI, which is artificial intelligence, you're talking about systems that are designed to act intelligently. They are systems, machines that are used to simulate human consciousness, right? So, for example, take your robotic systems, you talked about it. Amazon's Alexa is another good example. What they do is they can recognize human speech, they can identify objects, they can learn, plan, and solve problems like humans. ML, on the other hand, consists of models, process, and supporting technologies to AI, right? Algorithms that are trained with data. ML provides machines with the capability to adapt, reason, and provide generalized solution. It refers to a system's ability to learn on data, to train on a model, to evaluate the performance, and then make predictions, right? And there is also a subset of ML, which is our deep learning, which is used a lot these days, right? This is ML at its largest scale, involving millions of instances of training data and often are multi-layered neural networks. So deep learning, they kind of mimic your human brain. So from my understanding, I think this is AI versus ML versus deep learning for you, right? Yeah.
Okay. It scares me when you say it's going to mimic our brain, because I've been in my brain and it's not a place that we'd want anyone to go, but I get it. So if I can wrap that up, that basically AI is the general umbrella
Right.
under which machine
ML.
learning, or ML, is a subset. So that's one area of study and application. And
Correct.
under that, again, we have something even more specific, which is deep learning. So that's scaled with those multi-layered neural networks to actually generate the results and process the models. Is that about it?
That is right. You're spot
Okay.
on.
Okay. So the interchangeability, I think the challenge in the interchangeability is that while, going from a subset to a superset, sometimes can work. I think the challenge is maybe the associations people have with AI. We think movies and TV and, always the Terminator franchise, where it never ends well for people. Whereas machine learning is far more like, we have a problem. We're going to apply this technique to generate some insights and solutions to it that maybe people wouldn't have come up with, at this kind of scale. Is that about it?
That is right.
Okay, good. Thank you. I appreciate that. That's a good clarification that sets the stage so everybody understands the difference here. And today we're going to be drilling into machine learning, into that subset, because that is what we most commonly see advertised as part of products or services, where we see from cloud service providers, and obviously something of key interest to yourself as one of our principal data scientists. So before I jump into the next question, I just want to shout out Keith. Thank you for that comment. We appreciate the kudos for Lacework. We appreciate you as a customer. If you have any questions, drop them in the comments here. We will address them as this discussion keeps going. But let's dig, now that we know what ML is, let's dig into the real substance here. You said that this approach can help identify trends and patterns and in a lot of data. So why is this an advantageous approach versus getting people to try to do the same thing?
So recent advancement in technologies, right, and mining large data sets, we have map-reduce techniques, and ML can use this to review large volumes of data and discover trends and patterns that will not be apparent to human eye, right? For a human to sort through this massive data and make conclusions, identify patterns is impossible. So that is one advantage of ML. The second is automation with ML, right? It can cut workload and save time. We can let the algorithm do the hard work for us. So we don't have to basically go in every single day and look at reports to see what has changed. Is this okay? Is it staying normal, right? We can use methods like anomaly detections and then automate it. And then whenever there is anomalous behavior, we can create alerts that would send notifications to us, and that is the only time you have to go and look at it, right? So it cuts a lot of manual intervention or time that you spend looking at data every single day. Automation helps a lot. And with the ML is also super efficient in handling data, right? This is where you can have multidimensional, multi-variety data, and then they can do it in very dynamic and uncertain environments as well. So there are a lot of advantages of ML, and why it, like I said, it actually makes our lives easier in a lot of ways these days.
Okay, and just to clarify, because I think the what I've always talking to different people in different areas of expertise, we all use different terms and sort of different quantifiers in different ways. So what I may think of as a massive amount of data, you may think of as nothing. Right, you're just getting warmed up on a Tuesday kind of thing.
Right,
So
right, right.
when we're talking massive amounts of data for machine learning, are we talking like tens, hundreds, thousands, millions, billions? Like where on the scale does
It
that
can
fall?
be anywhere, depending on where your company is at, right? Some companies, they have I think maybe like 100,000 rows of data. And if you go into companies like Facebook, where you have to build for billion users, you have that much multiplied by the number of rows that the data set can have, right? So it can range anywhere, depending on the size of the company, depending on what you're trying to do with the data, right? Yeah.
Okay, and I think that really emphasizes the fact of why it's better than a person digging through is that, if I'm trying to dig through 100,000 rows of anything, that's going to take all week, right? And I mean, my eyes are going to glaze over and I'm not going to deliver quality results where the computer just churns through that and doesn't care, right?
Correct.
It goes, yeah,
Yes,
sure, give me another billion, I'll chew through that too.
that is
So
true.
that's really fascinating as far as the size of the data, because that opens up a whole bunch of possibilities that you just couldn't try before. With that, sort of keeping on that train of thought, what are some specific areas where applying machine learning techniques would really, really shine, really be useful?
Some of the areas that I can immediately think of, right? Your virtual personal assistant, Siri, Alexa, Cortana, have they not become an integral part of our life? I still remember a couple of years ago, my niece, who was 6 years old, was doing her math homework, talking to Alexa, right? Hey, Alexa, what is 4? 8 times 4. And that is how important Alexa was to her in doing assignments and stuff. Another area that I can really think of is like traffic predictions, right? These days, you want to get from A to B, you know how much time it is going to take, and it also gives you the best possible route available in from A to B, right? And these things we couldn't have imagined a couple of 10 years back. You need a map, you need to understand, you need to plan ahead. This has made travel so easy for us these days. So that is one of the areas where lot of data set is used and to predict traffic conditions in real life. And companies use customer lifetime value predictions, right? If you know your customers data, if you know what their behavior has been, you can come up with predictions on what offers to give them. Are they growing well? Are they churning? How do we give them better customer satisfaction, right? We can work towards those things. And detecting spam is another area. Spam filters are now creating new rules by using neural networks to detect spam and phishing messages, right? And another area which is growing a lot is product recommendations, recommendation systems here. So most of the e-commerce website today are making use of machine learning for making product recommendations here, right? Here, the ML algorithm, they use a customer's purchase history, their browsing history, and they match it to large product inventory to identify if there are hidden patterns and if they can group similar products together. And these products are then suggested to the customers, right? Therefore, motivating them to purchase product. And recommendation systems are used on Netflix too, movie recommendations that we used every single day. So yeah, I think these are some of the areas that I can immediately think of, using large data, but also like, where it has made our lives easier and where we use it a lot these days.
Yeah, and those are really good examples. And with that, Alex, thanks for jumping on with a comment. Really appreciate that. If you guys have any questions, if you have examples of systems that you've seen, in use that you want to call out, drop those in the LinkedIn comments as well. But what I find really interesting, Nithya, is those examples you gave were great in that they covered a lot of ground, but there's a lot of personal experiences there that most people have had. So, Alexa and Siri and the others, and of course, I've just set everyone's assistants off, and I apologize for that. All of those things, when we activate them, there's some level of it works or it doesn't. I think we've all had that frustrating experience where you're like, no, I meant this. And,
Yeah, that is true. They're not perfect.
yeah.
They're
And I
weak
think
AI,
that
right? They're not the strongest AI. The strong AIs, they exist only in movies and fiction. So, yeah.
And I would love the Star Trek level voice assistant that knows exactly what I want and can command the starship to drive me around. Because sometimes when I ask, one of those assistants to play music, the results are hilarious because I either feel like it's playing a joke on me. It's like, no, you don't want to listen to that. Listen to this instead. But then other examples like the product recommendations, it's almost eerie how accurate those can be in making connections that I never would have thought of. Yet when it's surfaced to me, I'm like, oh yeah, no, I'm interested in that. And similarly with the Netflix recommendations and stuff like that, is that they pop up and you go like, oh wow, I never really would have made that connection. So to see those sort of two ends of the spectrum, it highlights the everyday usage for sure, but also that they're not that we're not perfect here when it comes to machine learning, right? Is that
So
it's
with Netflix recommendation too, the more feedback you give, I think the more better it gets, right? The system learns and then does much better. Yeah.
and that seems to be a critical aspect, right? Is of those personalized recommendations is how much, and maybe that's an interesting contrast. Whereas Maps is more of a generic, like I know the routes, and based on traffic here, we're going to put you here. It doesn't matter who you are. Whereas for Netflix, my queue is very, very different than my partner's or the kids or other people in the family, because you definitely notice when someone starts watching under your profile for a while, and you're like, I don't want to see that. That's the other person, that's the roommates or that's the partner's view. So that customization is really fascinating. But I think this also brings us up to something else I wanted to ask is these are great examples, of varying levels of success. What are some bad choices or some areas where, people are maybe trying to force ML and they shouldn't be?
Right. So, like any system, right, though it is deeply integrated, there are a lot of advantages here. It isn't perfect yet, right? There are a lot of drawbacks. One is first, it needs huge, unbiased, inclusive data to train on, like and good quality data, right? I'll also emphasize on that later. And also, it takes much time to let the algorithms adapt, learn, and develop in order for it to come up with considerable amount of accuracy and relevancy, right? And another major challenge is the ability to accurately explain results generated by these algorithms. To go back on the unbiased, inclusive, good quality data, studies have shown that if we are not careful, racist, sexist, and abusive ideas can get embedded in these models, right? Say, for example, they could associate categories like doctors with men and nurses with women. A few years ago, a simple CEO search would come up with all white men, but that is not the portfolio of all the CEOs we have out there, right? So, very little research have been done to understand how the underlying flaws of this technology could affect people in real world applications. So, in short, the model is going to be as good as the data that you feed in, right? I think it is also a responsibility to figure out and design better ML algorithms that mitigate some of these challenges and do it very responsibly.
Yeah, and I think that's a really critical point. It's, it seems to be, garbage in, garbage out.
Right.
Um, that's fair.
That is true. Yes.
And I think that's maybe one of the challenges is that for the last decade or so, companies have kind of been like, I'm going to get as much data as I can. And there hasn't been as much emphasis on the points you just mentioned, the quality of that data, the integrity of that data, the level of bias included in that data. And we're finally seeing in the community, I think over the last 18 months, there's been a big upswell in a couple great books have hit the market talking about these challenges. We've seen even some services. So AWS launched SageMaker Clarify, which is designed to help find bias results in your data sets before you put them into the models and stuff. So there's awareness here, but I'm getting the feeling that we have a long, long way to go in this area of data science. Is that a fair statement?
It is, it is, it is. And we
Yeah,
also have
and
to do a lot of things to make it more like, even when we are doing data science in real life, we have to make sure we can make whatever we are saying, people can trust what we are saying, right? Yeah.
And so that ties into the actual title of the stream today, right? Mythbuster, machine learning can't be trusted. So this kind of works in perfectly to what I want to ask is that I'm hoping that this is in fact a myth and that we can trust well done machine learning. What areas of your work really focus on that trust part? Because you mentioned things like a black box algorithm, and I know most
Right.
people kind of go like, I don't know why it's making that decision. And if it's not something they would have thought of, there's a lot of, distrust. There's a lot of, questioning that right out of the gate. So what
Right.
aspects are deal with trust?
So I think we started the whole topic today with AI and ML, right? ML being a subset of AI, like, to act like humans, right? Intelligence of humans. But we humans are the most remarkably capable and autonomous system that can make decisions, right? So though we talk about trust issues with people, we do trust people day in and day out to do things for us, like, driving us, cooking, flying, whatever, right? That is because we see something, right, through demonstration, or we use our rationale to understand if we are on the same page with another human and if we can establish that trust. But when it comes to ML, like you said, it's a black box and it can feel like a black box and it will be like, can I trust it? So, as a data scientist or an ML engineer, we not only focus on models with high accuracy, but also understand the workings of the model, right? So that we can communicate our findings to our audience, explain in simpler terms what this model is doing. So that we could also, like, use methods to develop and deploy ML models that are not only accurate but also explainable. They are fair, they are privacy preserving, costs all, right? A few key points to keep in mind while building ML models is, like, examine your training data. Like, for sources of potential bias, make sure the communities are represented in a fair and equitable way. So you maintain data privacy and security all the time, right? That is a big topic these days, like, data privacy. And then be transparent, keep others in the loop, keep others informed, ask for suggestions, take feedback, eliminate your own biases so that, you feed in good data, like, without all these inconsistencies, so that your model also does much better.
So it's interesting the comparison to people, and I love your optimism around people. That's excellent. So we all need to have that sort of positivity, which is great. But also, I think the sort of the deeper thing here that you're implying and talking about is that we also don't trust everybody to the same level, right? There are gradients in trust, and a lot of people come to trust and think like I trust it or I don't, but really that's never the case. There's this level, and so I think we're seeing the same thing in machine learning, and that I fully trust machine learning to provide recommendations on my streaming service, because if it's wrong, like I click a few more times and I find what I wanted or something that's good enough anyway. Whereas if we're looking at real world implications, like I know I've a lot of when I was working for the government, we were looking in the early days for models to help process like immigration applications or citizenship things or public policy, and there where there's a bigger risk, then it's there's way more mistrust. But I think what you're talking about here is in those instances, well, we're not, that's where ML can help bubble up potential solutions that people can then take that
Right.
last mile instead of just letting the machine do the full decision cycle. It's not.
Definitely. Will you let AI handle your money? I don't think so.
I don't let me handle my own money, so I probably wouldn't let AI do it. But I mean, that's a great example too, right? Is that there's a real world consequence for that. And so it's not don't use the technology, it's figure out where that boundary is in trust so that you're comfortable with, I'm comfortable with it making some recommendations that I can then evaluate versus for, like that product recommendation or the streaming service or the mapping route. That's fine. You can figure it out. You're good enough at that. So I think that's interesting that, people, when you talk to them, because this covers data privacy, it covers the security conversations a lot, is everybody talks about trust as a binary, but we act on it as this gradient, and we need to do the same thing for machine learning.
100%.
So that kind of goes into the next area I wanted to talk about. We talked a little bit about it earlier as well, is the data, right? Is the data used to train these models? It's a massive amount. There's a huge amount of volume of data here to get good results. And, I think the more data you can put in, the better results you can generate out. But can you speak to the challenges in managing that amount of data and making sure that it's actually ready for use?
Definitely, right? Like, and again, like we talked about, good data is the key, right? Garbage in, garbage out. That is not exactly what we want. So we have enough data that is of quality, high quality, and enough to produce the results that you need. And like you said, it can vary between 1,000 to 10,000. What is that you really need to make your model more accurate? And is the quality of the data good enough, right? So you make sure your data sets are clean, they're free of errors, and also make sure there aren't missing values, because that will skew up the system, right? And another important process is you evaluate and adjust, and based on what you see, and if you're thinking this is not right, evaluate, adjust, do some sanity checking with the data, right? You don't have to go through the entire row, but if you're taking customer data, for example, you can at least study one customer to see if what your algorithm says is what you're seeing with the customer data, right? And then so make some I would say make some sanity checks with the data. Make sure it is good. You evaluate, and if it is not what you see, readjust the data. So fine tune your learning techniques until the ML algorithm consistently and reliably produces useful results that you can trust, people around you can trust. So I think that is a key with getting the right data and doing the right modeling here.
So this sounds suspiciously like the sort of iterative process we use in the rest of engineering, as far as, make a little change, go through the process to test to make sure things are working well, and then make another little change and keep going on that way, as opposed to, I think for some reason, myself included, I have a different concept of data science and machine learning. Like, no, you've got the data, you process it, you get your results, you're done. It's one time through. But it sounds like it's more of an iterative
More
process.
iterative. It definitely requires human interventions, right? So at least you make sure I think. So even when I do data modeling and data analysis, I take a few samples and then make sure what I see and what the algorithm predicts are intuitively is the same. So once you figure that out, I think that then it becomes much more easier.
Interesting. That's really interesting stuff. And this is, so we've bounced around. We've covered a whole bunch of different areas in machine learning. I think we've sort of shone a light on the process in general and some of where it's good, where it's not. And I think that's really important for the audience to understand, because it's such a complex topic. It's such an interesting topic, but it's hard to understand from the outside. I mean, you live and breathe this stuff. And the thing that I've seen working with companies around the world, helping them migrate into the cloud, is that the big three cloud service providers, so I'm talking to AWS, Azure, and Google Cloud, have done a really good job of making machine learning services available. So they've taken away some of the operational burden, and they generally have an approach of, there's a low level system, like here's a server pre-configured. If you know what you're doing, here you go. If you don't know what you're doing, there's a really high level layer where it's basically, give me a thing and I'll tell you about that thing. So here's an image, I'll tell you what's in it. Or, here's some text, I'll tell you what the sentiment is and what the constructs are it is. So that's pretty easy to understand. But then, there's this middle layer there's more knobs and levers to control, more trouble to get into, but more customization. And I think the challenge is companies hear about machine learning and they think like, oh, it can generate all these great insights. I think you've proven that that's possible if you know what you're doing.
Yes.
But if you, with a big, if you know what you're doing, if somebody is stumbling into this area, if they're just starting out, generically, what would be the sort of your top tips of how to start experimenting with machine learning? So not the nuts and bolts, like use this service, use that service, but like
Right, right.
workflow wise, what would you think would be a good start?
So, like I said, first, get what is a like get your questions right, right? What are we trying to do? Like first question is like what are we trying to do? What is the end result that we are trying to achieve, right? And then you understand if there is data that you have, or do we have to go and collect to substantiate, or to understand if we can get to the needed result. And then the third step is make sure your data is clean, make sure your data is high quality, and then you start with your modeling, and then you can pick a lot of different models in ML, from supervised learning to unsupervised learning. You have to decide, is this as simple as doing a linear regression, or do you have to really go into a complex method of neural networks and recommendation systems, right? And then once you figure it out, if it's a simple linear regression model, say for example, get your test data, get your training data, right, and do some cross validation, and then get your test data, and then make sure it is the accuracy is high, the relevancy is high. And that is how you start data science, right, on cloud or not on cloud. Cloud has a lot of advantages these days, because imagine if you have to do it without a cloud, right, where you have to download the data onto your local machine, which is also time consuming, resource constrained. So, and also you can't do anything with live data on your system because you're downloading from the databases, right? Going with servers also need planning. It's unpredictable, but cloud actually solves that problem. And then the elasticity of the cloud makes it a lot more easier. And then one advantage of cloud for data science is Mark said, it like a lot of open source frameworks are readily available for you, right? Say for example, if you want to install Apache Spark on your system, you have to first install Java and then Scala and then go on into installing Spark. But in cloud, it is readily available for you. And I think Google, Amazon, Microsoft, Azure, they have capabilities to run a lot of ML algorithms. But to dig more deeper into it, you can also go and check their trainings, right? They have a lot of training modules. You have to decide where you want to start with. Is it Google your preferred platform, or is it Amazon, or what your company uses? And go into their training modules, and they can point you to how to use your API and tools, and how can you do ML using that too.
That's fantastic. So two big things I took from that. One, the quote of the day, a simple linear regression model, which I think therein shows the difference between a data scientist at the top of the game and everybody else going, oh, okay. We know how to get started now, sure. But I mean, that's the difference of the human touch, right? Machine learning can be challenging, and you need people with that expertise and who have studied it and who have applied it repeatedly. But the second key thing I took from that answer was start with a question, and not just like, okay, I want to do machine learning now. Well, no, have a question that you'd like to get answered, and then machine learning could be a great way to answer that question. And then you can go through the rest of the steps that you mentioned, which is fantastic.
So always start with a problem, right? What are we trying to solve? And then clearly define your problem. The more clarity you have on what you want, the easier it becomes.
And that kind of actually comes back to something I just want to sneak in here while we're coming up on time. Is part of your iteration, do you often refine that question? So if you start with a question and then start going through the process, are you refining that question as well?
Sometimes yes, sometimes no, right? It is it also, again, when you take the data to the outside world, and there would be more questions, and they would challenge your thought process, right? At that time, if it is oh, maybe I should have, thought of all these corner cases, and I would go ahead and refine the question. Sometimes, your initial intuition and what you frame actually works. It also, again, it's very situation dependent, and what your leadership needs, what are you trying to do with, because we also work with other people, so take inputs, like I said.
Yeah. That's good. And so one of the things, and this has been a fantastic talk. I want to thank you very, very much for coming on. One of the things that I learned through this was that obviously there's a huge amount of computer science to get all this stuff so that you can process it. There's a massive amount of data science that goes into this, a very rigorous methodology. Make sure you've got the question, but there seems to be a level of art to it as well, with somebody with your level of expertise understanding that yes, this is the structure, but we can put our thumb on the lever a little bit here to adjust, to generate, to get the results that we're looking for, to be able to answer the question. And I'm really fascinated with areas of technology that are this complex, but have that level of you need that human touch,
Right.
ironically, for the machine learning results.
Data science sometimes is art, not just science. Yeah, you're
That,
right.
that's that's excellent. Nithya, thank you very, very much. I
Thank
appreciate you
you,
coming on
Mark.
today and sharing your expertise and helping everybody understand a little bit more about machine learning, where it's good, where it's bad. This has been yet another episode of Life's a Breach. Please follow us here on LinkedIn. Ask questions in the comments on this post. We do regularly look at them and join the conversation. We're looking for new topics for the next episodes. Obviously, we've got a few ideas, but we'd love to hear what you want to learn about, what you're thinking about, so that we can help bring on excellent experts like Nithya, who are at the top of their game, so that they can help explain their areas to the rest of us, so that we can get a little bit smarter. This has been Life's a Breach. Thanks for joining us, and we'll see you in the next one.
Thank you, Mark. Thank you, everyone.